We are picking back up in lesson 1.6. And in lesson 1.6, we were talking about all of our transformations. On Friday, we had looked at our translations, our left, right, up, down, and we had looked at our reflections across the x-axis, y-axis, and through the origin. And now we're ready to look at stretches and shrinks. Now, it does say state the horizontal, but we're actually going to talk about vertical and horizontal. So, state the vertical and or horizontal stretch or shrink of the given function. Now, based on the fact that the original function is, or the parent function, that's the word I should use there, is f of x equals x squared. So, thoughts on A. If my parent function is x squared, and then A is y equals 2x squared. Might need to flip back to the front of your notes where we had the chart. But thoughts on what type of transformation that is?
Vertical stretch.
Why?
Because it's greater than 1.
Okay. So, and if I flip back, 2 screens, Mario is suggesting vertical stretch. And I said why? He said because it's greater than 1. Why vertical as opposed to horizontal?
Because
It's multiplying out front, yes? It's just a whole number multiplying out front. A whole number bigger than 1 makes it a vertical stretch. And that's all I'm going to answer on that one. Okay? Some of these we're going to answer both ways, and I'll explain why here in a moment. But this one is a vertical stretch. By a factor of 2. So, one thing I will say, don't just tell me it's a stretch. Don't just tell me it's a vertical stretch. Don't just tell me it's a stretch by a factor of 2. I need to know vertical, stretch, and factor of 2. Okay, so get all those words in there. Don't try and shortcut so much that I can't help you out here. Okay, questions there? Okay, B. Y equals 4/10x raised to the second.
Horizontal. Or not compression shrink. Mario, it's been
Compression, shrink, I will take the words interchangeably when we talk about compressions and shrinks. So she's suggesting horizontal compression or shrink.
Yeah.
What if I disagree?
I think it's a stretch.
Is it vertical shrink?
No, it's a stretch because it's being multiplied by it, but it's in those parentheses.
Maybe we're all wrong. Maybe we should just stop.
I don't understand.
Well, and here's the deal. On this one, because it's in the parentheses with the x, but yet it's not division, we could actually manipulate this to go either way. And so we're going to talk what this is in terms of horizontal stretch or shrink, and we're going to talk about what it is in terms of vertical stretch or shrink. Okay, so it's kind of a tricky one because if you go back to the chart, for horizontal, it's supposed to be x divided by the number, yes?
Yeah.
And it's not exactly in the divided by form right now. Now, why did she pick this horizontal, though? Because it's in the parentheses with the x. So, what I'm going to suggest, we're going to go the more difficult way first, is changing this so it's in a division form so that we can talk about what kind of horizontal stretch or shrink this is. Now, let me lead you there. And let's talk about the fact, the decimal, 0.4. What do you know about the decimal 0.4?
Sure.
Okay. 2 over 5, because if read properly, which I didn't do on purpose, it's 4/10, correct? And 4/10 reduces to 2/5. So we can all agree that 4/10 is 2/5. And so this equation would be the same. Instead of saying 4/10 x quantity squared, we could say 2/5 x quantity squared, yes? Now, I'm doing this because I'm trying to get it in a fraction form. Right now, it's 2/5 times x. So x and that fraction are being multiplied. How do you change multiplication of a fraction to division? Actually, we usually do it the other way. We usually change division of fractions into multiplication, right? How do we change it, though?
It's like x over 2/5.
I'm sorry, what was the question?
Not exactly. We are going to flip numbers.
Sorry.
She's back. Okay, we are going to flip numbers. Not exactly like that, though, but keep in mind, if this was, say, x divided by 2/5, how would you change that to multiplication? If it's x divided by 2/5, you'd have to multiply by the reciprocal, yes? Okay, well, this is already in a multiplication, but can we reverse it, though, and think backwards?
Yeah.
Okay, and whether you think 2/5 times x or x times 2/5, what I'm trying to get you guys to recognize is that you can think of this as x divided by, not 2/5, but 5/2.
5 twos.
5/2.
5 twos.
Okay. Now, do we see the connection there? You guys know, because when division of fractions comes up, we always change it to multiply by the reciprocal. Okay, so that's just what I'm trying to connect there. Now, in this form, what is this?
Vertical stretch. Horizontal stretch.
Is her mind made up? Do we agree here?
Horizontal stretch.
Horizontal stretch? Horizontal because it's x divided by the number. Why'd she have to change to stretch? Because when you actually put it in that division form, this is 5/2, which is 2.5, right? Okay, so one way to express this, and I'm leaving some room underneath because we're going to talk vertical here in a moment. So this is a horizontal stretch by factor of 5/2, as evidenced by my work. Now, let's talk about what we could call this in terms of vertical. What's another way? Okay, so the first thing we did, I said, okay, 4/10, this is 2/5 x quantity squared, right? If I want to make this vertical, what happens if I do 4/10 x squared? In other words, what if I use that squared? Decimal in the wrong place, but right idea. 4/10 squared, excuse me, is 16/100 x squared.
Good job.
Okay. Remember, a 0.4 times a 0.4, there's got to be two numbers in the decimals then when you get done.
I have no room to write
So.
this.
Okay. Hey, well, now, with this in mind, if we rewrite this original equation as y equals 16/100 x squared, what do you see this as now?
Horizontal. What?
No?
Vertical stretch. Listen.
Oh,
I'm trying to figure out if I've gotten all the words together. I don't know if one person said all the right
Vertical
words.
A vertical
Yeah,
shrink.
Okay. Okay.
The bottom
So,
here is supposed to
it's a number multiplied out front, which puts us in the vertical category. That number out front is a number less than 1, so it's a vertical shrink.
I knew it.
There we go. Now all the wheels are turning.
So vertical shrink by a factor of 16/100. Now, does that make sense? How can it be both of those? Horizontal stretch, what's happening? It's appearing to be wider, right? Horizontal stretch, it appears to be getting wider horizontally.
Yeah.
What's a vertical shrink, though, do? It's kind of forcing it down, which makes it appear wider, correct? Okay, so it makes sense that it could be either or, right? Okay. Okay, C. Again, I see the parentheses. And basically, I guess what I'm telling you is when I see the parentheses, I want to talk about both of them. Try and help your brains understand this. So thoughts on y equals 5x quantity squared.
You basically just do what you did in the last one. Like you did that. Sorry.
Man, this AP bio test really killed brains this morning.
Yeah. You would just put x over x over 1/5.
What she said.
Yeah, what
Why
they
can't Mario
said.
answer these?
X
She's
I
the
do
one
that
going back and
totally.
forth.
Yeah.
How'd you get
Yeah.
where'd you get the one?
My bad.
I'm getting
Five
confused
over
You
one.
now.
have to do the reciprocal over 1. Oh, the reciprocal. Okay, never mind. I'm good now. I got it.
Okay,
Okay.
so
I got
the
that.
idea of multiplying something by 5 would be the same thing as dividing by the reciprocal. The reciprocal of 5 is 1 over 5. And I heard you guys kind of get that straightened out amongst yourselves, right? Because I heard the
So?
where's the 1, and I heard reciprocal, and
Oh.
okay. It's all together now, right? Okay, so multiplying by 5 is the same as dividing by 1/5. Based on this form, what is this? What kind of shrink?
Horizontal.
Horizontal shrink. It's x divided by the number, and it's a shrink because it's a number less than 1. So horizontal shrink by a factor of 1/5. The easier work probably would have been to go this way, right? At least in my mind, it looks easier to go this way. What's my other option here?
Just split the squared on 5 and the x, and then you'll have a vertical stretch by a factor of 20.
Okay, so 5x quantity squared can be rewritten as
Thanks, Mario.
25x squared. And so then when we write that, it's 25 times the function. So that is a vertical. This time it's bigger than 1, so vertical stretch. By a factor of 25. Okay, D, not as much writing for the struggle here.
I got like 2 inches of space.
Okay, D, y equals 1/3 x squared. What are your thoughts here?
Horizontal shrink by a factor of 1.
No.
No, vertical shrink. Vertical shrink.
No.
Well, it'll be a
It's
vertical
multiplying
shrink.
by a value out front. So that means we're in the vertical land.
And it's like 1.
1/3 is less than 1. So shrink. Okay, so this one, I'm just going to go that direction. I'm not going to try and go the horizontal because it's not the parentheses here. So vertical shrink by factor of 1/3.
I like that one.
So hopefully you left enough room to just write that. That's all I'm writing.
I did.
Nothing more. Okay, questions there. We see the connections, right? Okay, example 5. Finding equations for stretches and shrinks. The original function f of x is going to be defined to be x cubed minus 16x. Find the equations for the following non-rigid transformations of f of x. Okay, don't stress about the word non-rigid, just transformations. Okay. So, if f of x is x cubed minus 16x, that's my given, how do we do a vertical stretch by a factor of 3, given my original function of x cubed minus 16x. What's my chart say?
Put the 3 up front.
To do a vertical stretch, we're going to, okay, when we put that 3 out front, we are officially, what operation here? Multiplying, right? So I'm looking for the basic multiplication.
Okay.
Maybe someone said multiplication. I didn't hear it, but exactly, I didn't hear it. So I just heard throw the 3 out front, and
That's what I did.
That's what
Get rid of
I was
the 3.
looking for officially we are multiplying. That's what I was trying to get out of you. Okay, you just got to read my mind, okay?
Okay.
Now,
Got it.
okay, so if we look on the front page, it says, you know, it's C in this book, right?
Yeah.
CF of X.
Yeah.
You know, C, A,
I
whatever.
think so.
Yeah, C. So
Asterisk A.
my C value is 3 here. So I'm going to do 3 times f of x. Well, f of x is x cubed minus 16x, so we're going to do 3 times f of x. And then if we actually multiply it out, what does that vertical stretch by a factor of 3 look like?
3x cubed minus.
Mario, what's this one?
Mario, let's see.
48.
48.
X.
Okay. So a vertical stretch by a factor of 3, multiply the entire equation by 3, and there you go.
Have an eraser.
Okay.
Good team.
A horizontal shrink by a factor of 1/2. How do we demonstrate a horizontal shrink?
That's the other thing.
Okay, and what is that other thing? What are we going to do with the 1/2?
Opposite of what we did before, right? With the division instead of multiplication.
Okay. So,
Are we able to put like a decimal?
okay, so here,
Driver.
if we talk about a horizontal shrink by a factor of 1/2, starting place. Does that make sense for a starting place?
Yeah.
The fact that in order to do a horizontal stretch or shrink, you do x divided by the value, correct? Now, x divided by 1/2. I already heard the can we use a decimal, but pause that thought here. Because if I'm having to divide by 1/2, that's going to get kind of ugly kind of quickly. So think about your basic math skills here, guys. What do I know about x divided by 1/2? No, for
Oh, reciprocal. Reciprocal.
Oh.
to divide a fraction, you multiply by the reciprocal. So x divided by 1/2 is really x times
2/1.
2/1.
Change split. Because in 5th grade, I had to watch that video like 3 times and then I did it.
Okay, so the idea here, the direction I am trying to get us to head, is that in order to put the pieces into the equation, yes, we could do x every time we see an x divided by 1/2, but that doesn't sound very much fun to me. Okay, so instead of doing x divided by 1/2, I'm going to do x times 2, meaning every place I see an x, I'm not going to replace it with x divided by 1/2. I'm going to replace it with x times 2. And this is going to be equivalent. And keep in mind, this, you know, it's that whole stretch versus shrink thing. So, x cubed. Instead of x cubed, we're going to be doing 2x to the 3rd. In other words, every place I see x, it's now a 2x. Instead of doing minus 16 times x, it's minus 16 times 2x. Okay? Now, clean it up a little bit, and I'll be happy.
I get this now.
What is 2x quantity cubed?
2x cubed.
Disagree?
8x cubed.
8x cubed.
Because that 2 is in the parentheses, we're going to say 2 to the third and x to the third, so 8x cubed. Minus?
24x.
What?
24x.
Try again.
Yes, because I wasn't doing that in my head. 32x.
Okay, the math skills are a little lacking.
16 plus
We did
16.
some of the ratios this morning too, okay? We just gotta.
Okay, so a little bit, of just ways we can equivalate here, okay? Okay, example 6. The graph of y equals x squared. So same parent function graph that we had 2 examples ago. Undergoes the following transformations in order. Okay? Find the equation of the graph that results in, and there's 3 different things given, yes? So, we're going to go through this one by one because order matters here. Okay, sometimes a lot, sometimes a little. It just depends on the situation. So, first of all, if my function is x squared, how do I do a horizontal shift 2 to the right? How do I show that?
To put it in parentheses and do x squared next.
I thought I had it.
X minus 2.
So
If it's to the right, it's minus.
X minus 2 squared.
Mario, you're just thinking that everybody's first.
Yeah.
You should just,
Mario, I think.
Okay,
I'm
so,
just saying.
first of all,
Dang.
okay, in parentheses, yes. Okay, I heard in parentheses. The fact that it's left to right, we go opposite the sign. So since it's right 2, we're going to go minus 2. Now, the key is to make sure when you put it in there with the x that we have to scoots the exponent over, right?
Yeah.
If we just say x squared minus 2 and put parentheses around it, it's not really a horizontal, it's still a vertical. Okay, now we're going to take that equation and we're going to do a vertical stretch by a factor of 3. How do I show a vertical stretch by a factor of 3?
multiplication of 3 on this x.
And where are we going to multiply that 3?
Distribute, like you're distributing.
Except we're not actually going to distribute.
Well, we leave the 2.
So we're just going to say 3
But it's gonna look like it bigger. If that makes sense.
times x minus 2
we're
squared.
not actually distributing.
I'm not going to distribute because, first of all, that's not just x minus 2. That's x minus 2 squared.
Oh, shit.
So I would have to FOIL that x minus 2 squared out before I could distribute. And we're not doing that.
That brings back, like, PEMDAS. Like, I was just thinking, like, would you do the exponent or would you do the...
e to the
Okay.
e to the m.
And then a vertical translation, 5 units up. How do I show 5 units up?
Adding.
And where do we add this 5?
Just to the end.
Okay.
Because remember there's like an H and a K formula for that.
There is, yep. It's in vertex form is what it is. And so your vertex is 2, 5. Okay. This right here, guys, is a resulting order. Now, could I have just written that out in all one step? Yeah, I could have, but I'm trying to show you how we're adding on each step. Now, we're going to go backwards. So we're, again, of course, starting with x squared. We're going to go up 5 first. So how do I go up 5? Y equals x squared plus 5. Okay, it's after the squared, after the x squared. Okay. Then, vertical stretch by a factor of 3. How do I show a vertical stretch by a factor of 3?
3 in the parentheses x squared and plus 5 on the other side.
I am so confused. Yeah.
Not exactly, I don't think.
You don't have to put it into the parentheses. It can just be 3x squared plus 5.
Disagree.
Or would it be 3 in the parentheses x squared plus
Here's the
5?
deal. We've already moved it up 5, yes? And now we want to stretch it by 3.
Yeah.
So we're going to take this whole piece and stretch it by 3.
That's what I thought. Yeah.
So you have to have parentheses around the entire piece, which is what makes this different by going in this opposite order. What makes it different than last time?
The whole thing isn't square.
No, the whole thing is not squared. My squared is still on my x. The whole thing is stretched by 3.
So, what do you do when you have to do the horizontal?
You subtract it from 5, right?
Okay. Horizontal shift 2 units to the right. Well, where does a horizontal shift go?
And if it's
It still has to go in the parentheses. It still has to go with x. And so, my 3 is going to stay out front. We're still going to have parentheses around x squared plus 5. But x squared is not just going to be x squared now. It's going to be, actually, you know what? I'm even going to change this outside parenthesis to a bracket if that helps. But x squared is going to become x minus 2 squared plus 5 is still in the parentheses there. Okay, so the difference here is because of how it worked, now, because I did my vertical translation before my stretch, we're going to move it up 5, and then those values are going to be stretched 5.
that makes more sense.
Okay? And so that's, you know, again, the order matters here. Because you graph these are not going to be the exact same equation or exact same graph. Okay, they're going to be similar, but they're not going to be the exact same. Okay. Example 7, if you guys are ready here. Okay. And this is not the best graph, but we're going to make it work. Okay. This given right here is your graph. Okay. This is our y equals f of x. The graph of y equals f of x is shown. Determine the graph of the function y equals 2 f of x plus 1 minus 3 by showing the effect of a sequence of transformations on the graph of y equals f of x.
Why didn't they give us like something easy to like
Heaven forbid we
whatever
make it
this
easy
is?
to be.
Okay, well, first of all, a line would be actually more difficult because it's hard to like stretch and shrink a line. Like that doesn't.
Something not this.
Okay.
My favorite
And
part is
what
how
we're going to look at
they're
specifically
straight.
is there's a point here at negative 2, 0. There's a point here at 0, 2. And there's a point at 4, 1, correct? Those are going to be our key points that we're going to use. Okay, just so you kind of are, you know, like those are the points that matter. The rest of this, it's kind of a curve and then a line. I don't care so much about that. I just care about you getting the points in the right spot. Now, thoughts on which we should do first.
The moving to the left one.
Okay. So there's an x plus 1 here. It's in the parentheses, so that is going to be left 1, yes. And again, that's the innermost option there, isn't it? So we're going to move left 1. Now, I'm putting here the kind of the x plus 1, indicating, okay, we're going to do the x plus 1 piece.
Wait, is it on 4-1 or 4-0?
4, 0. I said 4, 1, didn't I?
Yeah,
I meant, yeah, read my mind.
it's okay.
My mind said the wrong thing. Okay, so I'm going to put some tick marks in here. I think I can go 3 each way, and I've got plenty there. So my point that was at negative 2, 0 is now going to be at negative 3, 0. My point that was at 0, 2 is now going to be at left 1, so negative 1, 2. My point that was at 4, 0 is now going to be at 3, 0. Okay, I feel like mine's a little more stretched out than the example.
Is this a parabola or
Oh shit,
It's-
I forgot to move that.
It's not a parabola, no. It's because it's a straight line on the right and kind of a curve on the left.
Isn't that
It's
the
just-
absolute
No, it's just a curve and a line. Don't try and put it into. It's just a graph.
It's absolute value.
Okay.
It's a V.
If you make it like absolute value, fine, whatever. But it's not absolute value either. So okay. Okay, so that was the moving left one. What's next?
Oh, I was gonna stretch it.
Officially, if we're kind of using the idea of PEMDAS and what is on the X, you know, what's done closest to the X, the stretch should really happen next. Now, I will say, you could have stretched and then moved to left one. You could reverse those first two. Stretch, then left one, or left one, then stretch. Those would be reversible. The -3 at the end is not reversible. Okay, you'll get yourself in trouble if you do that one first. So this one, we're doing the 2 times f of x, if you will. Now, let's see. Still going to go 3 left, 3 right, 3 down. I think you need to make sure you go at least 4 up. Okay, then go 4 in all directions then. Okay. So what kind of stretch is this? You guys probably said it at the time, I just didn't write it. It is a vertical stretch, yes? And that matters because which values are we stretching? Vertical values. Which are the vertical values? Y's, yes? Okay. She got there. Okay, now, so we're going to stretch the y's. At the point, -3, 0, that I'm at right now, what is my y value? 0. What's 2 times 0? 0. So what is that point still? -3, 0. When you stretch something or shrink something that's on the x-axis, it doesn't move. Okay? Now, the point that was at -1, 2. When we stretch that, what's my y value currently?
4,
2.
Oh.
And then when we stretch it by a factor of 2, 2 times 2 is going to be 4. So I'm at -1, 4. And then, what is it? 3, 0. When you vertically stretch, 3, 0. Well, what's the y value? 0. And 2 times 0 is still 0. Okay, so now, something like that. It got taller, right? It stretched up. It got taller. Makes sense? And this is why it matters, because if you move this down before we stretch it, that's where the graph isn't going to look right. So that's why it matters that we get this done, the stretch done first. What's the last piece we have to do? -3 is moving it down 3, right? So take each of those points and move them down 3. So this is doing the f of x -3. I think you can go back to, as long as you have 3 tick marks on each side, you have enough. If you're going to go back to being symmetric, Noah. So, let's see, what am I at? -3, 0. When I move that down 3? -3, -3. -1, 4. When I move that down 3?
1, 1.
-1, 1.
Okay.
And 3, 0. When I move that down 3? 3, -3. And should look like the shape we just did, but moved down 3.
Oops, good.
And that's just, I'm trying to get you guys to think about the pieces here, right? How do we actually do our transformations? Okay, your homework is due tomorrow. It's on page 131. And it's 2 through 32 evens. And you have a little bit of time to use to work on it.
Can I borrow your scissors?